in this video we'll be looking at the concept of fractions. Alright, so some of the things that we'll be looking at today will be defined in fractions. We'll also be looking at how to correctly label a fraction. We'll be looking at the different types of fractions, how to convert from an improper to mixed fraction and vice versa. And we'll also be looking at how to manipulate fractions using the 4 basic operations. Let's start off by looking at the definition of what is a fraction. Alright, so according to this piece of information, a fraction represents equal parts of a whole. Alright, so let's assume that this thing was drawn to scale. Of course, it's not drawn to scale, but let's assume that. Now, let's say this rectangle right here was split into 2 equal halves. One half is shaded, as you are seeing right now. Now, we can represent this diagram using a fraction, right? And that's what we did right here. So this one right here represents the shaded area, all right? So that's the one right here. So this represents a shaded area, and we could have had so in this diagram we have 2 halves, 2 equal halves, all right? So the denominator represents the possible 2 halves that we could have shaded. Alright, so that's how we could represent this diagram right here as a fraction. Now, we can also label this thing. Alright, so that top number has a term that is attached to it. Likewise, this thing right here and the bottom number. Now, we refer to the top number as the numerator. Right? So that's the name of the top number when we're dealing with fractions. So we refer to that as the numerator or whatever is in the top. Alright? So if we are working more complicated fractions, then whatever is in the top, we refer to that as the numerator. So the numerator refers to what's in the top of the fraction. So the one right here represents the numerator. The bottom number right here, which is 2, represents the denominator. Now this line right here, or should I say line segment, that separates the numerator from the denominator, we refer to that as the fraction bar or vinculum. Alright, so that's pretty much what a fraction entails of, alright, in the basic sense. Alright, now let's look at, so we have covered the definition and we have looked at how to correctly label a fraction. So now, please remember these terms. We'll be using those terms further on in this video. So I'll be referring to the top number as numerator, the bottom as denominator, and sometimes this line here as vinculum. So types of fractions. Let's look at the different types. All right. So there are 3 major types of fractions. All right, and those include proper, improper, and mixed fractions. Now we are going to be looking at them individually. So proper fractions. What makes a fraction a proper fraction? Now a fraction is proper once the numerator is smaller than the denominator. Alright? So once the numerator is smaller than the denominator, then we refer to that type of fraction as a proper fraction. Now look at these examples down here. So all of these examples meets the criteria of being a proper fraction because the top number, which is the numerator, is smaller than the denominator. Alright, so if you view all 4 examples, and of course we could have had many more. Alright, doesn't matter how large the numbers get. Once the numerator is smaller than the denominator, we refer to that as a proper fraction. Alright, now we have improper fraction. Alright, and of course I know many of you probably already could have figured out what this thing would have been. All right, so the term improper pretty much means that this thing must be opposite of what a proper fraction is. All right, so a fraction is improper once the numerator is larger than the denominator. All right, so that's the difference between a proper fraction and an improper fraction. So in the proper fraction, the numerator is smaller. In the improper fraction, the numerator is larger than the denominator. All right, as we can see in these examples right here, all of them meets the criteria of being an improper fraction. So notice the numerators are larger than the denominator in each example. All right, and again, it doesn't matter how large the numbers are. All right, so we could have continued many more out there. All right, so that's an improper fraction. Now, how about mixed fraction? According to this information right here, it says that this is a fraction represented with its quotient and remainder. All right, now the term quotient, I know that this term might be foreign to some. Quotient pretty much, this refers to the result that one obtained after dividing two numbers. All right, so this is the result that you get after dividing numbers. All right, so according to this, it is represented with its quotient and remainder. Pretty much, in layman terms, that pretty much means you would have a whole number and a proper fraction. That's typically how we represent a mixed fraction. So we have a whole number and a proper fraction. So, and of course, we could have had a whole number and an improper fraction, but this is typically how it is written. So as you can see in every single example that we have here, we have the whole number, then the proper fraction. All right, and we could have had many more of that. So once you have a whole number and a proper fraction, we classify those as being a mixed fraction. All right, so the whole number would represent the quotient and the proper fraction represents the remainder. All right, so that's what they mean by with those big terms right there. Now, there is another fraction. So those are the three major types of fractions. But there is another fraction that I want to introduce you guys to as well. All right. So this fraction I want to look at. So this fraction, we call it an equivalent fractions. All right. So equivalent fractions rather. So equivalent fractions, according to this thing right here, when two or more fractions have the same result after simplification for which they represent the same portion of the whole, then such fractions are equal to each other and are called equivalent fractions. All right, so let's look at what this thing is saying to us. Now let's say we have 1 over 2. Don't want you to pay attention to that side as yet. So let's say we have 1 over 2. All right, now we can write a fraction that is equivalent to this. Pretty much means they are the same thing, just written in another form. All right, now we can get an equivalent fraction by simply multiplying the numerator and denominator by the same number. All right, so that's what we did right here. So multiply the numerator and the denominator by 3. And of course, we could have done that with any other number. All right, we could have done that using 2, as we use 3, 4, 5. We could have used any number. Doesn't matter how large that number is. Once we multiply the numerator by that number and the denominator by the same number, we can then obtain an equivalent fraction. All right, so notice right here we have 3 times 1, which is 3. 3 times 2, 6. All right, so 3 over 6 is an equivalent fraction for 1 over 2. All right, so we can do that to obtain an equivalent fraction. Now we can also leave from 3 over 6 and go right back to 1 over 2 by simply reducing this thing right here. All right, so we can reduce fractions also. So look at this thing right now. Now we can reduce this thing by simply dividing both the numerator and denominator by the highest common factor. Alright, by that I mean we can divide 3 and 6 by the highest number that can go into both these numbers without leaving a remainder. Now that number would have been 3. So 3 can go into itself one time, alright, and 3 can go into 6 two times. So we end up back with 1 over 2, alright. So we can do all of these things. So we can do a lot of things with fractions, alright. Now let's look at this example right here. Now here we have 8 over 12, alright. And we could have done the same thing just like we did right here. We could have multiplied both the numerator and denominator by the same number and obtain an equivalent fraction. Or again, I chose to reduce this one, so we could reduce it by dividing both the numerator and divide the denominator by the highest common factor for both numbers. So in this case, the highest common factor for 8 and 12 would have been 4. Alright, so that's the highest number that can go into 8 and 12 without leaving a remainder. So 4 goes into 8 2 times, 4 goes into 12 3 times. Alright, so 2 over 3 is an equivalent fraction for 8 over 12. Alright, and by now you can figure it out that we can have several equivalent fractions for a given fraction. Alright. And again, we can also move from this thing right here back to the 8 over 12. So we multiply both top and bottom by 4. Alright. So 4 times 2 give us the 8 right there. And 3 times 4 give us the 12. Alright. So that's pretty much equivalent fraction. Alright. Now, the next thing that we can do, we can convert. Alright. As I mentioned in the initial stages of this video, we can convert from improper to mixed and vice versa. Now let's look at how we do that. Now here we have 3 over 2. Here we have 3 over 2. Now we can write this thing. This is an improper fraction. As you can see here, the numerator is larger than the denominator. Now we could write this thing as a mixed fraction. Alright, now let's look at how we do that. Now, this one right here, which is the whole number, represent what? It represents the number of time 2 can go into 3. Alright, so 2 go into 3 one time. Alright, so that's how we would get the whole number right here. So the whole number represents the number of time the denominator, which is the bottom number, can go into the numerator, which is the top number. So that's what this one represents. So 2 goes into 3 one time, leaving a remainder of 1. Alright, so after you take 2 out of 3, 1 will remain. That one, we put that one in the numerator. Alright, now we keep the common denominator right here. So we keep the 2 down here. So that's how we rewrite this thing into a mixed fraction. Alright, so you can always rewind this video and watch that to get, if you are not clear on that. So again, 2 going into 3 one time, leaving a remainder of 1 that we'll put in the numerator right here, and we keep the denominator. Alright, now let's look at this example, second example right here. It requires us to do the same thing. Alright, so again, the whole number represents the number of time the denominator can go into the numerator. So 2 goes into 7 3 times. Alright, so 2 goes into 7 3 times, leaving a remainder of 1. So after we take 2 out of 7 3 times, we'll be left with a remainder of 1. Alright, and we keep the common denominator, which is 2 in this case. Alright, so 7 over 2 is the same thing as 3 and 1 over 2. And that's how we convert from improper to mixed. Now let's look at the other way around. And if you observe, these are the same examples. So I want to show you how we move from the mixed to improper. Same examples. Now look at this thing right here. This is how we do it. We'll find the product of the whole number and the denominator. Alright, by product I mean we'll multiply these numbers. So 1 times 2, that gives us 2. 1 times anything remain the thing. So 1 times 2 gives us 2. we'll then add that product to the numerator. So that 2 that we get, we'll add that to the numerator. So we'll end up with 2 plus 1. All right? So 1 times 2, 2 plus 1 give us a 3 right there. And that's how we get the numerator right here. All right? And again, we keep the denominator, which is 2. All right? Same thing over here. 3 times 2, 6. Add the numerator, 7. All right? So 3 times 2, 6 plus 1, 7. Keep the denominator right here. So that's all to it. So that's how we would convert from improper to mixed fractions. All right? So that's all to it. Now let's look at how to add and subtract fractions with like denominators. All right? That means that the denominators are the same. All right? Now we have some steps laid out here. So step 1, we must make sure that the bottom numbers, which is the denominator, are the same. All right? So we must ensure that the denominators are the same, else it wouldn't be classified as being a like denominator, fractions with like denominators. All right? That means that the denominators must be the same. All right? Step 2, we add, that this depends on which one we're doing, we add or subtract. So adding and subtracting is pretty much the same thing required. Only thing, the signs are different and we know what to treat with each sign. All right? So, but the same thing is required for both. So we add or subtract the top numbers. So once the denominators are the same, given the operation that we have to deal with, let's say we're doing an addition, we add the top numbers, which when we say top now, we're referring to the numerator, and put that answer over the denominator. That would have been the common denominator. All right? Step 3, we simplify the fraction if needed, or if it can be done. All right? Sometimes the answer that you get, you won't be able to simplify it any further. But in this example, all right, we have created something that we could have simplified. So let's look at example 1 to get a better understanding of what those steps entail. All right? So this is step 1. So we're ensuring that the denominators, which are the bottom numbers, are the same. So notice here we have 1 over 4 plus 1 over 4. Here we want to ensure that the denominators are the same. So that's step 1. All right? Now, once the denominators are the same, we can then do what? We can then add, because this is an addition sign, we would add in this case. If it was an subtraction sign, then we would have subtracted. All right? But because this is an addition sign, then we add the numerator, so we keep the common denominator, which is 4. So both denominators are the same, we keep the common denominator, which is 4. We then add the numerators, so we have 1 plus 1. So 1 plus 1, this is step 2. And this will give us now 1 plus 1 is 2 over the common denominator, which is 4. All right? So this is step 2. So we add the numerators once the denominators are the same. We add the numerators and keep the common denominator. We can then reduce this thing now according to step 3. So we can reduce this thing, 2 over 4, we can reduce that by dividing both the numerator and denominator by the highest common factor for both numbers. So the highest common factor for 2 and 4 would have been 2. 2 goes into itself 1 time, 2 into 4 goes 2 times. All right? And as you can see right here, 1 over 2 is an equivalent fraction for 2 over 4. All right? So this is just a fraction in a simpler form, but it's still a half. All right? So I hope you were able to get that. All right? Let's look at a subtraction example. Let's look at this thing right here. So a subtraction example. Here we have 3. We have 3 over 4 minus 1 over 4. Now again, so step 1, we ensure that the denominators are the same. Then we manipulate now. Now we can therefore manipulate. All right? And these numbers aren't correct. So in the numerator, we should have had 3 right here. So we should have had 3 right here. And this sign should have been subtraction. Alright? So I hope you're able to make out that correction right there. So here we have 3 over 4 minus 1 over 4. So this thing now, in the numerator now, we ensure that the denominators are the same, step 1. Then we subtract the numerator. So we have 3 minus 1. So 3 minus 1. 3 minus 1 gives us a 2 right there. And we keep the common denominator. Alright? And then we know that 2 over 4. We can also write that in a simpler form, which is 1 over 2, which we explained in the previous example. Alright, so just to make a note of that, to ensure that you get this part right here, remember this is 3 minus 1, so that's pretty much what's in the numerator. So 3 minus 1 gives us a 2 right there over the 4 equal 1 over 2 if we write that in a simpler form. So what we did there, we simplified the 2 over 4. Alright, and we got 1 over 2. So that's pretty much that. Alright, now what do we do when we have unlike denominators? Alright, what do we do when the denominators are different? Alright, as we see in example 1 right here. Here we have 1 over 3 plus 1 over 6. Now according to step 1, we must make sure the denominators are different. Alright, so we have to ensure that this problem meets the criteria of being a unlike a fraction with unlike denominators. Alright, so we must make sure the denominators are different. That's the first thing. Alright, so we must know what we're dealing with. Alright, step 2, find the lowest common multiple of the denominators. So we must then find the lowest common multiple of the denominators. And of course, any multiple would have worked. But if you use the lowest common multiple, then it makes life much easier, alright? But any multiple can work. Just want to make that clear. Alright, so here we have 1 over 3 plus 1 over 6. Now the lowest common multiple, what that means the lowest number that both 3 and 6 can go into without leaving a remainder. Alright, and that number is 6. And this is how we set this thing up. Alright, so we draw a vinculum like this. We'll leave a little space right here. Alright, and you will soon see what goes on this line right here. We put the LCM, which is the lowest common multiple, underneath that thing right there. Alright, now step 3, we then do what? We then divide the LCM by the denominators, then multiply the quotients obtained by the corresponding numerator. And again, remember, so okay, we have that in NB right here. The term quotient refers to the result obtained after dividing two numbers. So remember that. Alright, so this is what they're talking about now in step 3. So what we do right here, we do what? This is what they're talking about. So we say what? 3 goes into 6 2 times. Alright, so that's what we do. So the quotient is pretty much the amount of time 3 goes into 6. So 3 goes into 6 2 times. We'll then multiply the amount of time this 3 goes into this 6 right here by the corresponding numerator, by the numerator that goes with this fraction. Alright, so 3 goes into 6 2 times, 2 times 1, and we'll write that result on this line right here. Then we'll put down the addition sign, and then we'll continue. 6 into 6 goes 1 time, 1. Alright, and we'll bring that down just the same. And you'll see that in this aspect of the video. Alright, so this is what I was talking about, which is step 4. So we just pretty much solve after that. So after we would have carried out that thing right there, so we divide both denominators into the LCM, alright, and then multiply the corresponding numerator for each fraction by the number of time its denominator goes into the LCM, alright. So I hope you were able to get that. Now let's look at this thing now. we can solve and simplify. All right, that's the final step in this thing right here. So as I was saying, 3 goes into 6 2 times. 2 times 1 give you a 2 right there. We put that on the line right there. We bring down the sign that separates the fractions, which is an addition sign. All right, 6 divided into 6 goes 1 time. 1 times 1 gives you a 1 right there. 2 plus 1 gives you 3, and we keep the denominator, which is 6. And we know that we can reduce this thing. All right, so we can reduce this thing. So we divide both top and bottom by the highest common factor, which again means the highest number that can go into both 3 and 6 without leaving a remainder. So 3 goes into itself 1 time, 3 goes into 6 2 times. So 3 over 6 is also the same thing as saying 1 over 2. All right, so 1 over 2 is an equivalent fraction for 3 over 6. All right, let's look at example 2. The same thing applies if it was subtraction that we were dealing with. All right, so again, we divide the denominators into the LCM. So 3 goes into 6 2 times. 2 times 2 gives you a 4 right there. We bring down the sign. That's the only thing that's different, the signs. So we bring down the subtraction sign right there. 6 into 6 again goes 1 time. We use that 1 to multiply the corresponding numerator right there. So 1 times 1 gives you a 1. 4 minus 1 gives you 3. We keep the denominator, which is the LCM, which is 6. All right, and again, you know how we get the 1 over 2. We pretty much reduce this thing or simplified it. All right, as I explained in the previous example right here. All right, now the final 2 operations that we'll be looking at, and they are the easiest ones. All right, so these are multiplication and division. All right, very easy. All right, so when multiplying fractions and dividing fractions, we don't find an LCM. All right, a lot of my students tend to make that error, but I just want to make it clear. All right, so when multiplying fractions and dividing fractions, the rules are different from when you add and subtract. All right, so what you do when you add and subtract, multiplying and dividing fraction, that's different. All right, so let's look at how we treat with multiplying fractions and dividing fractions. Let's first start with multiplication. Now step 1, we must, so here we have an example. All right, so 1 over 2 times 2 over 5. Step 1, find the product of the numerators. Step 2, find the product of the denominators. That's all to it, you know. That's all we are required to do. So here we have the numerators in red. So this thing right here, we just simply do a multiply the numerators. So 1 times 2, we draw a vinculum or fraction bar right there, and then we multiply the denominators. 2 times 5. So 1 times 2 gives you a 2. 2 times 5 gives you 10. All right, 2 over 10, and that would have been your answer. All right, but we know that we can always simplify if we can. All right, especially if sometimes the questions ask you to write the answer in its simplest form. This wouldn't be the simplest form. All right, so we can also simplify the fraction if necessary. All right, so here we have the answer, which is 2 over 10, and we can reduce that by dividing both the numerator and denominator by its highest common factor. All right, so the highest common factor for 2 and 10 would have been 2. So 2 goes into itself 1 time. 2 goes into 10, 5. And remember, highest common factor refers to what? The highest number that can go into 2 and 10 without leaving a remainder. So that's it for multiplication. That's all it entails. All right, another way how we could have done this thing. All right, so I'm just going to give you another. We could have reduced first. All right, so all right, I want you to ignore this side of the problem. So ignore this side. Let's look at this. We could have reduced. So we can use something in the numerator to reduce something in the denominator. All right, that's another approach that we could have taken. So for example, we can say 2 goes into itself 1 time. 2 goes into 2 1 time. Sorry, 1 time. All right, so that's a 1, that's a 1. All right, so 2 goes into itself 1 time, 2 goes into this 2 also 1 time. So we use this 2 right here in the numerator to cancel this 2 right here in the denominator. Alright, so we could have then multiply across now. So we can say 1 times 1 is 1 right here. Alright, so I want to ensure you're seeing all of this. So 1 times 1 gives you the 1 right here. 1 times 5 gives you the denominator. Alright, so you would have gone straight to the answer if you use that approach. Alright, but the easy way to do it, I guess both ways are easy. You could just multiply across as I showed initially, or you can reduce it first, then multiply both the numerators and both the denominators. Alright, that's it for multiplying fractions. Alright, and again, you can always the good thing about YouTube, you can always pause the video and rewind it and do what you need to do to get a better understanding of that. Alright, now let's look at how do we treat with the division of fractions. Alright, when dividing fractions, how do we go about that? Alright, now when dividing fractions, that is very much different to the multiplication of fractions. However, after you have completed the first step, then you will then end up in a multiplication scenario. Alright, so let's look at that. Alright, let's say we have 1 over 2 divided by 5 over 4. Alright, the first fraction, we're going to call that the first fraction. The second fraction, alright, call that the second fraction, so we can understand them distinctly. Alright, so look at the first step. We'll turn the second fraction upside down, which means we'll flip it. We'll call that the reciprocal. Alright, so when you flip that fraction right there, you will get the reciprocal for that fraction. So we'll flip the second fraction. Alright, so 5 over 4 becomes 4 over 5, which is the reciprocal. Alright, so 5 over 4 becomes 4 over 5. And remember, we are reciprocating the second fraction. That's very important. Alright, not the first one, the second fraction. Now step 2. So step 2 now will then multiply the first fraction by the reciprocal. So the reciprocal, remember this reciprocal right here that we got? Alright, so the 5 over 4 becomes 4 over 5. 4 over 5 is the reciprocal of the second fraction. Alright, so what we'll do now, we multiply the first fraction by the reciprocal, which is when we flip the second fraction. Alright, so the first fraction was 1 over 2. We multiply that by the reciprocal, which is 4 over 5. And we know how to multiply. So this is pretty much a multiplication scenario now. But remember the first step. Alright, so that's the only step that is different from multiplication. Alright, so that's why I say it's pretty much different, even though we'll be doing multiplication in it. Alright, so now we multiply 1 times 4 gives you 4, 2 times 5 gives you the 10 right here, and we can always simplify these things. Alright, so we simplify the fraction if needed, and in this case we can simplify this thing. So what we'll do, we can divide both the numerator and denominator by the highest common factor. Again, that's the highest number that can go into 4 and 10 without leaving a remainder, and that number is 2. Alright, so 2 goes into 4 2 times, 2 into 10 goes 5 times. Alright, so 2 over 5 is an equivalent fraction for 4 over 10. Alright, and that's pretty much how you treat with fractions. Alright, I'll be creating some other videos demonstrating how to work more complex fractions. Alright.